Okay. I leave it unmuted, right?
Yeah, start sharing.
Start sharing.
And then change the webcam and mic to this one.
Change the webcam. The BT.
Yes.
This one? The
Yeah.
speaker.
No. Speaker. Yeah, speaker.
Okay.
And then audio. Webcam. And then the camera. Are you going to stand up at all to talk about circuits or no? I think your intro slides are in the other slide deck.
Yeah, I'm gonna go back. Okay. Okay.
Last thing.
Oh my God. This is a whole situation. Hello?
Yep, you're good.
I'm good? Okay. Okay. Hi, everybody. I am Victoria Nguyen. I'm currently the Vice President of CPP Hyperloop. I also was the hardware team lead last year. I'm kind of just doing more administration work this year. It's my senior year. I'm like a 5th year studying computer engineering. And my primary focus in my career, but also just in technical work, is PCB design. And yeah, so let's just get into it. Okay, so first section, we're gonna go through like a couple sections. Essentially what we're gonna do is we're gonna talk about the setup of Altium Designer, which is one of the softwares that is primarily used in a lot of big tech companies. A lot of companies also use Cadence. Chris is teaching TiCAD, but unfortunately it's not used as much in companies because it's just not as advanced for any kind of needs. So what we're going to do is we're going to go over the setup of Altium Designer first, and then we're going to talk about the circuit, the voltage regulator circuit you guys have been hearing about the past few workshops if you've been attending, and then we're going to go straight into Altium Designer and start our PCB. So first section is setup. Oh, this is interesting. Oh no, I didn't know. Oh, okay. So this is our setup page. Let me share this with you all really quick. If you are on the Hyperloop server, I'm going to share this with you. So please open it up. It's going to give you a lot of information on our project today. If you don't have it, who's not in the server? Oh, nice. Okay. That is in the announcements channel. Please let me know if it doesn't work. Otherwise. Okay, so this is our third revision of the PCB workshop. So if you haven't attended the past two, they are in this slide. They're also super stuffed into the server. The Altium Designer first workshop, we kind of went over the logistics of PCB design, like what is the point of PCBs. I think I'll just share right now, which essentially, on the other hand of not having PCBs and having a breadboard with a bunch of wires, a bunch of stranded components on there, logistically, it's not very efficient for any kind of project. As like, for example, we're talking about like the soccer bot. I think our soccer bot this year had a little breadboard, and I heard it worked great, but then you have some errors of like, what if it falls over and now you're going to have a wire missing? There's issues like that, and on top of that, that's level number one. Level number two is what if you wanted multiple circuits? So you can do multiple circuits on one PCB. You can stack a bunch of different PCBs together. For example, that's how a flight computer is made. It has a bunch of different PCBs that are able to control the mainframe of the rocket. If we're talking about rocket companies. So that's what we went over during Altium Designer 1, which is like, what's a footprint, which is like the 2D model of a component. What's a 3D model component, 3D model component. Yes. A flight computer. So a flight computer essentially is a multitude of PCBs in one side of a chassis, right? So for example, your phone has, maybe an Apple phone has one PCB. So there's like microelectronic PCBs or micro PCBs are very small. There's larger ones that are able to handle more voltage, more current, depending on the project that they're being used for. But like, for example, your phone just only has one PCB because it doesn't need to have that much capability. But a flat computer needs like 3 strings, for example, like 3 different flat computer boxes. For example, if one of them breaks, you have a multitude of them, or a fail-safe design, essentially. So something like that, different projects have different requirements. So Designer 1 workshop was talking about like how do we kind of have the right terminology for that, so you can go over that in your own time. Designer 2 workshop was creating our own PCB and kind of how to use Altium. So there's a lot of good stuff in those 2 workshops. You can look at that. But before even we start any of this conversation, raise your hand if you have the Altium Designer installed on your computer. Okay. If you don't, just do it right now. It should be not that quick, but it'll be good by the time we work on our PCBs. So is that like, just install that right now. Raise your hand if you have the library loader. Okay.
Yeah, how do we tell?
It should. Yeah.
I access the link, but I don't know what
if it's installed, if you go under tools, if you're in Altium, if you go under tools, it'll be like symbols, footprints. It'll be like its own unique section under one of the panels, or under one of the. Yeah, exactly. If you don't download that now, quick note is, what's your name? Yeah. Chris. Like Chris said, it can get lost. So just make sure that you have the directory down just in case. But it should be fairly easy setup. I've posted that here. I've posted that on the announcements page as well. That one should be really quick. And then if you want to not start early, but if you want to get ready for when we do create our PCBs, you can look at the create new project, and we're going to go over it, but that's essentially everything we need to know to set up. So now we're going to get into creating the PCB. But first, so there's like a bunch of things that I went over in the previous workshops. It's like, what are you supposed to know as a PCB designer? And obviously, first, you can't create a PCB without the circuit, right? There's no point. So we're going to go over the voltage regulator circuit PCB. I assume, from what I'm hearing, that you guys have went over this circuit multiple times. So if you have any questions, we're gonna fly through it as quickly as possible. So what's the point of a voltage regulator circuit? So like Chris said, you guys went over this a bunch of times, but what we're gonna do today is turn the circuit that you guys have been looking at into a PCB. So the theory, the point of a voltage regulator circuit is to be able to put in a bunch of power, or be able to tear apart voltage, essentially, because you don't want, for example, if you have a computer and you overload it with voltage that it's not able to handle, it's going to blow up. Same thing. Now I was just telling some people, I was like, if you put too much food in your belly, you're going to blow up. It's not going to happen the same way, but same point. So essentially what we're doing here is that we're going to have a 9-volt battery be able to come out into outputs of 3.3 and a 5-volt. 3.3 volts and 5 volts. And this is because around 5 volts is when you can power up an Arduino. 3.3 is for RF. So essentially, at the very end of creating your PCBs, you'll be able to fabricate them. I don't know if I have to say that now. That's a surprise! So I don't know if that's for the very end, so I'm still looking at Chris. But eventually, you'll be able to use them, solder them, and do whatever you want to do with them. So there's a bunch of different things that come into this, which is that there's a big problem with just having a full 9-volt battery, or just essentially that idea, because batteries don't really add up to 5 volts. For example, if you do like a AAA battery, it's like 1.5 volts. You have that little decimal area, which is a little bit inconsistent, and even then in the circuit, there's a bunch of uncertainty that we have to work with. So we're just gonna kind of run down through the circuit, and then I assume you guys have some brief knowledge, so I'm gonna run through it quick. But so at least from what Chris is telling you, you guys have learned about the black box concept, which is essentially, if you don't remember, if you have a black box. So the black box will be called your PCB. So you have two inputs, right? You have a 9-volt input, and what we're going to do is we're going to take it out into 3.3 volts and 5 volts. But how do we get from 9 volts to these two different sectors? What we're going to do is we're going to daisy chain the two AMS ICs. Because otherwise, you just have a bunch of transistors. Because inside of these ICs are just a bunch of transistors. Inside transistors, there's a lot of noise already. So how are we going to take care of the noise inside of there and also just not create our own transistors here, right? So we're going to use something that's already been made. We're going to run through it. So we have one header, which is our input. We're going to switch it to a little switch over here. This is the switch that we decided to use. And as you know, if it connects to 1, the circuit, the current will run through. If it connects to 3, it'll be turned off. And we're not connecting it to ground. I'm saying this now because when you guys create your PCBs, you connect to ground and create the short. So something to keep in mind. Then we're going to run it through the diode. When it runs through the diode, it's going to go through these caps. And the difference of why we have two different caps is because how we draw it. So essentially, current's running through, right? And it's like super fuzzy. But there's a bunch of different signals going on in here when like current's running through, right? So what we're going to do is we're going to add a really large capacitor, which is around 10 microfarads. And essentially, the bigger the capacitor, the bigger signals are going to be able to like be blot out. So essentially, if you add a capacitor and then 10 microfarad, it's going to still go like this. Like you don't have the big spikes anymore, but you still have this small signal. And ultimately, in a circuit design, you want the most cleanest possible signal coming out, especially if it's going to hit some other signals coming in. For example, the 5 volts going to go to 3.3. So if we add a small capacitor, which is 0.1 micro, it's going to still have obviously a little haziness. You can't find perfect results in electric. So that's why we have these two capacitors here. And essentially, we want to make sure that we can check out what's going on. So we have the resistor, obviously current can't run through a diode without some kind of resistance running through it. So we have one diode here, and the green LED won't turn on without the 10K, and all the resistors are going to be different for each LED. So that's the very first point. We're going to hit to the first IC, which is where we're going to run down 9 volts into 5 volts. So we're going to run over here, and then once we're over here, we have the two caps again. Then we're going to check it out again to see where are we at now. Because there's a bunch of different issues with just noise in general. You're not, like I said, you're not going to find the perfect value out of everything. So we're just going to keep in mind like what's going on in the circuit. There's a lot of experimental data that actually happens when you're testing the circuit. So we're going to have another switch up here that goes into the header, so you can check out there should be around 5 volts. Another LED, we're going to run it down to 3.3, so this is for RF and this is for your Arduino. And we're going to run it down to another 2 capacitors to another header for your next LED. So just cool terminology is that this apparently is called daisy chaining. Chris has really good terminology. You guys are want to talk to him about that. Yeah, I mean, there's just, yeah.
Daisy chaining means that there's a close place. Yeah. Slaves. It's like a decentralized. I don't make them. I just
Okay, good to know. But let me see if there's anything else I want to hit. Yeah, so yeah, and I assume you guys have been working with your screw terminals, LEDs, resistors, all that fun stuff. Are there any questions before I move on from the circuit? So you guys have good knowledge on this now, though. Okay, so now that I have the circuit, so we're going to get into the PCB design preparation. So right now, everyone open up your Altium designer. I know.
So
You
this,
have.
we're going to sit up now.
Okay.
All right,
Well,
so at this point of the workshop, if you guys are KiCad, we're going to migrate to the next room over.
Wait, not yet.
Not yet?
Not yet.
Just kidding, not yet.
Not yet. Sorry, just thought about stuff. Okay, so this is a quick from the other workshop, just to kind of everyone should know this if you're doing PCB design, is preparation for it. So essentially what we just did was, the team was electrical engineers. We came with you with a circuit. Now you have to build the circuit on the PCB. So essentially when you have your first rendition talking with the electrical engineer, you're gonna ask them like, what are the specifications of the circuit? Is there anything I need to know specifically? Obviously it's very good that you know what the circuit does, but there's some things that are more important in my opinion. So like if it's a high voltage regulator, which is we're just doing a voltage regulator, high means there's high voltage, which is like there's different clearances for it when it comes to manufacturing. You're doing a flyback converter, power distribution board, and then there's things that you need to know: is there RF in it? Is there Ethernet in it? Because every single design has their own unique capacity to handle some sort of amount. So that means like current. RF needs a lot of vias, which are basically volts of the board, because there's a lot of heat, and RF is a very sensitive signal. So things like that. And then eventually, after you talk to the electrical engineer, you talk to the mechanical engineer. They're asking like, with your phone, like I was saying with Chris, like we have a PCB in here. Okay, well, what else is inside of it? Well, we need to fit it inside a box so people can actually use it, right? So the mechanical engineer will come in like, well, this is the size of the box. I don't want to work with this round, so your PCB has to be smaller than this dimension, ABC. So that's the mechanical engineering. Manufacturing engineer comes in and like, is this even possible? Do we have the money? Do we have the resources essentially to do it? And then also depending on how advanced your company is they'll tell you like, we can only print one at a time, or we can only print 5 at a time. There's stuff like that where you have to like just talk to every single person. And then that's when we get to PCB. So after you do your PCB, then you get into release, you get into manufacturing, you buy it, purchase it. Then usually either you, if you're the electrical engineer, will come in and test the board to make sure it works. After this one, you can take that. But so need to know as a PCB designer, I think this is like a huge point. So I actually have been interning as a PCB designer for a while now, and it wasn't until this very year, like what are the specific things I need to know them. If you're really going to take your board from concept to release. So you need to know as a PCB designer is how, like I said, how big is your board going to be, layer count. So there's like 2-layer boards, there's 16-layer boards, there's, do that. And it's also important like what kind of material they want to use, because that affects your board as well. So materials are cheaper, I guess to say, higher quality, whatnot. And then you, like I said, you want to talk about max current, max voltage, your manufacturing parts. So Chris and I have talked. He was my electrical engineer, and he decided like these are the parts that I want to use. So I'm going to show you guys the BOM later. But usually the electrical engineer tells you that your specific placement, if the header needs to be on the side of the board, inside of the board, wherever it wants. Mechanical features, manifolds, and then specific signals, like I said, RF, Ethernet, whatnot. And what's the point of the board, and then manufacturing guidelines. So we're gonna get started. Oh, that's awkward. Okay, we're just gonna go with it. So this is the design. Oh my god, this is embarrassing. Okay, the design workflow. So we have the create the project first. Oh, this is hilarious. Okay, so we have to create the project first, and then we have to create the schematic, right? So usually your electrical engineer, unless you're like a startup or whatnot, you usually have an electrical engineer first before a PCB designer, because you can't create PCBs without electrical people, right? So you'll create your schematic circuit. Like I said, the electrical engineer usually make it, but today you guys are gonna make it. And then we're gonna, you guys can skip this part. I just thought it would be a good point to know about, which is your stack open design rules. Fortunately, because this is kind of a less complicated board, Altium already comes in with the guidelines. But don't worry about it too much. I'll figure it out later. The stack up's already there. We're going to talk about what this next board is going to look like, and then you're going to go into placement and your board outline. So you're going to define like how big the board you want it to be, such, and then specific signals. Oh my god. Oh wait, this is yeah. Okay, and then placement, routing. Routing is just fun Tetris, and then release. That's basically it. So this is your board today. I'm as an electrical engineer coming in with your requirements. So your voltage regulator circuit's going to be a 2-layer single-sided board, which means everything has to be on one side. This is the purpose so that when you guys actually go and release and you are able to solder on your board, you can kind of lay them down and solder them on. So that's that. It's 2-layer single-sided. Then this is a very cheapo version of what a bomb looks like. But basically, your screw terminals, these are part numbers for every single screw terminal. This is very specific. This one's pretty specific. These three are specific. Your resistors and capacitors, I'm going to show you the circuits inside this presentation. But the package size should be a 1206. This is because you can actually have space to solder it by hand. Does anyone have questions? I know this is specific, very specific. Any questions on this?
For resistors and capacitors, by the way, the 1206 is representative of the SMD size. SMD stands for surface mount device. So these devices are going to be soldered on the top of the PCB and won't go through all the way. So if you guys are in KiCad, you'll see a lot of the components are split up into SMD and THT. So if you choose an SMD part, just know that it would go on top of the PCB. If you choose a THT part, which stands for through hole, it'll go all the way through the PCB. So for the last workshop, you guys have been using through hole components because these resistors, capacitors, diodes, these LEDs will go all the way through a PCB or a breadboard.
Yes, they have little lines sticking out of them. TLDR. So then the other ones are just like on board. Both are pretty easy to solder. But don't worry about that because we're just making the PCB today. So here's your cheat sheet. And this is very important because, yeah, we don't want you. So just going to run through it really quick. Remember to control S. Altium is a very, I don't know if KiCad's very.
Yeah.
Okay. All PCB design software is very fidgety, especially because we have the library loader. And the library loader is like another layer of software on top of the software. So if it crashes and you don't control S, sorry, buddy. Yeah. So that's very important. Control S whenever you can. And then all the other stuff is kind of like just things that you can know when you're actually using the software. Origin is the base point of where your grid's going to follow. So that's important that you start with that. Annotations, we'll get into that. Orientation of headers. So when we go to the 3D side, like obviously a header can't be sitting inside the board because how you're going to. So like, you want to look at the 3D model to make sure that's the right orientation. The new mechanical layer, just so you have a board outline, and then that's going to be how you set your piece. So now.
All right, so if you are in KiCad, we're going to begin building the board and the schematic and everything. So if you're in KiCad, you're going to go to the next group, which is 429, I believe. If you guys are using Altium, you can stay here and maybe we'll go through the process of building the PCB. Now, what's my grade? I'm going to go and break it.
I don't have to do anything else, right?
No.
No. Okay. I'm going to take this picture out.
Yeah, supposed to happen.
Okay.
I'm not there. I'm not sure.
Bye.
Go to the home page.
Bye.
Oh yeah. Look.
See you later.
Go to the files.
What?
I don't think
Oh, you
it's
did?
library.
A bit closer.
Yeah.
I'm taking L's. Oh, because that's page. Oops, Daisy. Okay. Is everyone good? We good to go?
I have a question about the library. Can you show us how to show, like, to ensure that we have it installed?
Yes. So, first and foremost, I am deleting this picture out. Sorry, guys. You got it, though. Hope you had a good reference. We're going to go over good design rules during it. But essentially, you're pretending you're the PCB designer. There's no other product that's been created like this. So you are the creator of your own world.
Are you using it for manual labor?
No. Well, this is okay. So actually, I'll let Chris give you guys the surprise. I shouldn't have said it. But this is more so just to get you guys on your feet, on your toes about PCB design. And if you come to the next workshop, you'll be able to have your own voltage regulator PCB. So that's good to know. If you want to get into the, like, if you guys have any career questions, if you guys want to get into the electrical engineering area, it's very good to have PCB design on as a skill. because you're basically taking on 2 different jobs, which also is an increase in your salary. So that's dub. And so we're gonna get into the PCB. I'm gonna close this. I'm gonna close this. We're gonna close this. Okay, so how do you see your library loader? You should be able to see. Oh my goodness. See, is very not great, especially if your computer doesn't like you. Okay. You'll be able to see your library loader once we've created the project. Yeah. Sorry. Realized that was a very okay. So first things first, we're gonna create our own file. So you're gonna go. Does everyone have it up? Are you waiting for anybody? Okay.
I still have a question.
Yeah.
I'm having trouble downloading it completely. I'm not even downloading.
Which one?
The Altium.
The Altium. Yeah.
I clicked on the link and I created the account and everything, and then I just put it download.
Did you just sign up right now?
I'll try to download via VPN.
Thanks. Okay. Yeah, it takes some time for Altium to get back, unfortunately. But since we're on a little time crunch, Sam's gonna help. Okay, so everyone else, while we get into this, we're gonna create our project. So you're gonna go to File, New, Project. You are gonna get this window pop up. You want to rename your project, so you can say voltage regulator, or hey, that's me. I'm gonna do Hyperloop voltage regulator. Do whatever you want. ASDFG, I don't know. Okay, it's also important to notice where your folder is. Isn't too important, it's just so that you can locate it. I'll show you guys easy path for it. So you press create. Ta-da! We've created our project. Uh-huh. Yeah, so you go to new, or you go to file, new, and project. Yeah. Yeah, add in your name and create the project. So does everyone have that? Great. Okay, so now we're gonna talk about the logistics of, wait, who actually saw the workshop 1 or 2? Okay, so we're very fresh on PCB. Cool, that's fine. Okay, so it was last semester, yeah. Yeah, it's a little, yeah, I know, you're totally fine. I know. Our count is fine. Okay, so the hierarchy of a project essentially is the main frame of a PCB design or project, electrical project. So you have your .prg PCB. That project folder is going to hold every single thing you have for your project. That means your schematics, your PCB, a bunch of schematics. So the hierarchy is within a hierarchy within a hierarchy. You're going to have your bombs in there. You're going to have your Gerber files. We'll talk about that later. So now that you have your project PCB, what you want to do is create your schematic. So you can go right click, add new to project, schematic. And while we're at it, right click, add new to project, PCB. So as you can see, you have your schematic document and you have your PCB document. The dots are pretty important, that they correlate with each other and that you don't have hanging free documents. This means you're not working within your project. And if you save it, it's going to be separate and they're not going to correlate. So I'm going to tell you guys that later. So now that we have the schematic, here's we're going to create it. If we go to panels really quick, you want to pop up properties. And just after designing the first one, the schematic sheet is actually really small. So how you do that is you pop up panels, properties, sheet size. And what I found is that sheet B works the best. It's perfect. Legal. What's legal?
size sheet.
It's right here.
Legal.
Oh,
Or letter, I guess, for the years.
yeah. Oh, that's fair. Okay.
Whatever you want.
Well, up to you guys. Whatever fun you guys want to have. Properties, and then go down to formatting and size, standard, legal, sheet size. So, I'm going to share this photo so you guys don't have to jump back and forth.
Oh, you got it.
Does anyone have any questions?
So are we supposed to see that diagram right now?
The sheet. Yeah, so you guys are going to be creating this in a second. But we're going to go over how to get your library loader first. So, how to get your library loader is you go to, so you have to be on your sheet first of all. You go to Tools, Symbols, and Footprints, just see there. If you guys follow the library loader, shit on that.
Yeah.
Otherwise, you only see up-down hierarchy.
I see up down.
It's only up-down hierarchy. Okay. Okay. Is that everybody? Who actually has library loader? Okay. If you have, do you see it in Altium? Do you see it? You have it, but it's not. If you have library loader on your Altium, let's do a quick run and get everybody in. Yeah? Go. Okay. If you have library loader.
It's not even logging. I don't even have Altium. I haven't gotten the password.
Oh.
I did it last night because I saw the email that said, and I didn't confirm the email.
Oh, I'm sorry. Yeah, it's a little like I didn't really.
Okay.
I'm trying to download it now, like creating a login.
Yeah. I'm computer today. Yes. So follow the instructions. Okay. Who has it and needs help?
Install the library loader and then the design.
It's just so bad.
Oh, you have to go to right click and have this Is there anybody else that needs help with library loader?
Wait, I already have it in here. This Altium database library version 2.
Yeah, but you just said about.
Right. You know how I get the function? I mean, I haven't installed it.
There
To
was
give it
a
off.
way there was a sheet that's wrong.
Okay, anybody else? Fair notice, if you don't have it, you cannot create PCB schematic.
And Altium preference. Component available. And then you
Okay, it sounds like everybody has it.
It's the menu button. File based library.
Okay, for those that do have it, process is pretty standard. So remember, first thing, Control S, because your entire project will be wiped if you don't do that. So when you Control S, you want to save it into your project above it. So the Hyperloop voltage regulator is what I named the project PCB. We're going to save the schematic document. Oh, you can rename it too, just because it's more fun. Just kidding, you should rename it. Voltage regulator. Oh no, I'm gonna put yeah, voltage regulator. And it's good to know, it's good practice is that you want to, I forgot what this is called, but you want to make sure the very first letter of the new word is capitalized. Because, for example, you're going to have a bunch of PCB, like schematic documents when you enter a company and they want you to do this. Camel case, that's right. Nice. I suck at terminology. Another thing you want to do is actually just might as well save all documents. So we're going to save your PCB doc as well. You want to rename that, so voltage regulator .pcb doc. And because they have different extension names, they're not going to be the same thing. Okay, so first things first, we have your schematic. You can't do anything on the PCB doc without a circuit. So I posted the picture here, but how are we going to find everything? So if you go to panels, you go to components. It's going to pop up your components. And initially with this license, you have the capability to enter into the miscellaneous devices and miscellaneous connectors library. I assume you guys both don't see this. Oh, you? Really? Yeah. I was like, wait, that's cool. Because I took 10 times to download this. So essentially, we're going to go over really quick the libraries. So you have your devices libraries. It's very limited. So usually when you go to a company, if they're actually pretty big, you have PCB librarians. PCB librarians are people that take care of the library. So they create the footprints if you have customized footprints, depending on your industry, whatnot. So your devices, like your diodes, your capacitors, all the fun stuff, and you have your connectors. If you look in here, so you have your headers, a bunch of different headers depending on what you need, but it's very generic, and that's why it comes with it. But what we're going to use is also the SAMaxis, whatever, library. So how you do that, how you add it in, is you want to press these 3 buttons, file-based library preferences. Then what you're going to do is you do need the directory to that library loader that we just installed, right? So you're going to press install, and you are going to find that directory. And when you find that directory, it's probably going to show up like this, like there's nothing in it. And this is because it's searching for integrated libraries, which is connected to your miscellaneous connectors integrated library. But SAMaxis is a little bit different and labels it a little bit different. So you're going to go to all files. You're going to import in your PCB in your schematic lib, open it, and install it. I've done that already, so I can't do it again.
I wonder if it adds the double.
Actually, it does. It doubles it. Just kidding. No, it doesn't. It sometimes wipes the directory to the miscellaneous devices and connectors. Yeah. Yeah. My computer is super messy. It gets mad.
So I have override protection from this stuff. So if it recognizes that an override occurred, then I authorize it.
Yeah, this software is definitely buggy. Does everyone have it in? Who doesn't have it? Okay. Where are we getting stuck at? Just shout it out.
Yeah.
Okay, so 3 lines. File-based library preferences, install. Then you need to find the directory to where your the Altium library loader was located. We can find,
Just hold on. I bet that's 10 minutes for this, except maybe it's not. It's not.
if you don't have that, we can actually try something else. So you can go to tools. I'm gonna write the entire thing down.
How do you get the PCB library? I only have like that with library file.
Oh, that's terrible.
I feel like I'm never free.
Is anyone lost?
Oh yeah, I don't know where to get the PCB library file. I have like a database library file, like integrated library package, and like all of that stuff, but like you don't see like PCB like. It's really the
Is this under your Altium library loader?
I don't think so, but.
yeah, that's it tells me to clone the thing to clone all the library.
Okay, so no,
And then
clear to me.
eventually once it's like Altium,
Let me go backwards. Maybe you guys can see what my director looks like. Oh, I added it in. Okay. Your directory might be called Altium LL. I imported this folder into my Altium. If we don't have that, let's try something.
Yes.
Oh. Okay. Now I got it. Cool. Okay. Let me see if this situation is going to work really well. So our device is AMS 1117. Okay. How I popped this up was I went to Altium, Tools, Symbols, Footprints, 3D Models. This is going to give us the directory to your footprints. So it's voltage regulator AMS 1117.550. Yeah. So let's try that one first. So when you do that, search. And what we're going to use is that advanced monolithic systems. But for this, because I haven't downloaded it yet, we're going to see this one. So you press it, you press add design. Oh, no, okay. So it already exists. I already downloaded it. Okay. Oh, here's an easy way to find it. So if you go, do you guys have this little window open up .schematic library, the stamps Maxis, when you do that?
Yeah, just really.
It's even if you can't find your library. This is how you're going to find your directory. You don't have that? Who has the footprint actually open? That one and this one.
Does anyone not have PCB stuff like everybody's able to see that, right?
Okay. Anybody? If you have a question, raise your hand so that either me or Sam can get to you.
Search up the specification that she gave you. I think she gave you. You're good. You got it. She's gonna give you the specific part number that you need to use.
Yeah, I got it.
The way you got it.
Oh, yeah. Now, what should
I use all two.
I know, I remember this. I remember seeing this.
Let's go there.
I followed the website.
Okay, well that's the footprint, or that's the map. So we're gonna add, you go to channel.
Yeah, because I don't know the letters. I clicked symbols, blah, 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 and now I clicked this, and symbols and components.
Oh, that's when you write that.
Components.
Wait, what's the question? Oh, okay, I got it. Let me just, yeah, everybody. Okay, so what we're reviewing with everybody, what's going on? So you guys don't have this Maxis inside of your guys' preferences, right? So what you're gonna do is you're gonna copy this, Control C. Or take a look at this location. I don't know why the Control C is important. So when you press this, the 3 lines, file-based library preferences, install. You're gonna Control V. Oh, it doesn't. But point is, go to right before it says. Do you see how it says the Altium?
I know, but then she clicked.
So right before it says .pcb live, you want to get to this directory. Whatever is right before your .pcb live or your .schematic live. You want to run in this directory, and when you're there, install. Usually what you see is this. You don't see anything, right? So in order to see it, you have to scroll this down and say that you want to see all files. And when you see all files, you're going to click the schematic library and the PCB live. Yeah, my link location is right there. It's different for everybody. Someone's like, got it. You got it?
When we're at the Maxis images tab, then we go on the bottom right.
Yeah. Wait, give me a second.
So, what was it? Install, right? It's just
We have another small file. Scroll down. Your extensions aren't shown. So I'm pretty sure the icons. Now sublime. Let me just show you guys what mine looks like. If your extensions aren't showing, they're like this little schematic symbol looking thing. That's an IC. And then the other one you're gonna download is this one with like the logic on it.
Usually the file type is PCB library and then
yeah. Some people don't have their extensions showing. So the ones you're gonna be downloading, try that one. And then one change. And then also. And then there should be it. So you press close. Then you can see the drop down. And now you have it.
Oh yeah.
Okay.
Like I get to like actually make sense of how it works.
Yep. Okay. Close. After you guys open it, you just close it. It's already installed. Yep, close it, and then when you have it, you should be able to open your. Once you have it, if you pull this down, oh my god, I have like 4 of them. You should have 4. Yeah, I have 6 because Sam messed with me. Now I have 4 Symaxis. We tested downloading it twice, and now I have 4 Symaxis libraries.
Oh, let's go.
No, let's not go. I don't know what I hope they're connected. I don't know. Whatever. The point is, yeah, okay, so does everyone have it? Once you have, okay. So now it's there. So now we create the circuit. This is what we're gonna do now. That was a whole illustration. Huh?
Is there a way to make sure it's there?
Yeah, if you just drop it down and you see it, it's there.
Yeah, I got it.
Yep, got it. Okay, so now this is we're ready now.
Because I see that you have it, you left, I don't have it, but I left.
Oh, okay, so we're gonna go over that too. Thank you for saying that. Okay. Is everybody good? Everybody have your Symaxis. Now it's all you. Literally, I cannot do anything else. Okay, so we're gonna do a quick rundown on how to use Altium. Who has used Altium? Besides Sam. Okay. So these are called panels. There's a bunch of different panels that exist. There's different panels on your schematic document, and there's different panels on your PCB document. As you can see, I'm on the schematic library, which is a free document, which means we're not actually working inside our project. So you want to press back to your schematic document. And primarily what you're going to be using here, the panels that you're going to be primarily using on your schematic document are your components panel and your properties panel. And usually you'd see it sidebarred like this, which means it's going to close when you're not using it, which is really annoying. So you want to open it, pin it. If you want to pin it, it's up to you. Altium is like very flexible, but buggy. So there's a bunch of different things. Don't really worry about the rest of them. This is my projects panel on the left, just so I can kind of route to whatever I want to touch. And then these are your little file headers. Oh no. Oh, we're back. Okay. So this is how we're going to start. So I have posted the circuit inside of announcements, and essentially what you want to just start doing is dropping down all the things. So like we did earlier with the voltage regulator IC, what you do is you go to tools and then you open the footprint symbols like we did earlier. Symbols, footprints, and then add it in. And that's how you grab all of your components. There's a little bit of a difference because the BOM is in the presentation, but what we want to focus on during this PCB round is you want to first go to your miscellaneous connectors or devices library, look for a component there first. If it doesn't exist there, then you go to your library loader. Does that make sense? So don't do the opposite, because then you're going to have a lot of random manufacturers. For example, they're all going to create like the same thing. Some people have like better quality. That's not the point. Is that we want to primarily focus on the general pieces and then go from there.
I have a general question. So, as a PCB designer, are you given the schematic and then you just put it into the software, or do you have to build the schematic with whatever requirements they have?
Yeah. So, question on that end is it's very broad per company. So I interned actually at SpaceX as a PCB designer, and because it's a bigger broadband company, we have electrical engineers that should. There's different teams, right? So there's like power teams, there's digital team. Usually those teams will automatically go through like PCRs, which is like product reviews. Whatever. I never attend them. Point is, they'll already come in with the idea. So like they're a group of people. They're going to sit down with the kind of manufacturer, electrical. They're going to create the project PCB doc that we did, and then they're already going to create the schematics. They give that to me. But for example, like I worked with the EMI team, and they don't really use Altium. So they're like, we have this data sheet, and we just want this IC. Can you create a schematic? And I'm like, okay, well now I have to talk to them, like what kind of capacitors do you want included? Like what is the point of it? So it depends on the company, it depends on the industry, depends on the resources. And the use, yes.
The thing is that you can design like a PCB, you need to be conscientious about like what PCB is going to be used for. For instance, it has to be like RF stable, right? Like it's not throwing out a bunch of junk that like you don't want to interact with other stuff or whatever the case may be. That's very specific and important, especially with routing.
Yeah. And also like you'll never really see only one schematic page. This is like non-existent. Separate practice. Like usually like oh my god, I didn't want to get into that. Like a PCB high voltage regulator project I worked on had like 40 pages. So
the thing that I ended up learning for
like that, yeah, it just gets crazy. Point is that so you want to start placing down your components, like I said, miscellaneous devices and connectors first, and then yeah, just start having a little fun. The BOM. So I'm gonna put these side to side. Where's the BOM? I just had that. Why did I do that? That was silly. Okay, this is the BOM. So that means for the resistors or capacitors, what you guys want to type in, because I'll give you guys a cheat sheet to quicken this up. Resistors and capacitors do not exist in the miscellaneous devices. They're going to exist inside your Altium loader. And when you want to add them in, you're going to write res. So like if you want to look for capacitor, you can do cap 1206. And if you want resistor, res 1206. And make sure it's an SMD. So the footprint's going to look like that. That's an SMD part. A real whole part. It's like this. Yeah. What?
There's more than one SMD component like that.
Okay, yes, true. I feel like I'm just thinking about the resistor. It looks like her.
Okay.
Yeah, not all of them have that. I was just thinking about the cap.
Oh, yeah, okay.
Yeah.
I'm with you.
I'm saying like look for the ones that look like this.
Yeah.
Like don't look for ones that look like this. We're not using those.
Yeah.
Actually, that's okay. Any questions? You guys can just start building out your schematics.
If we're not looking at, don't want to look at the library first. We want to look at basic parts. Where is it?
Oh, actually. Okay, another cheat sheet. Nothing exists for the circuit on miscellaneous devices.
Okay.
I looked for it first, so I did you guys a hard labor. So everything exists on Altium library building.
Okay.
At least for this circuit. Yeah. Yeah. Just give you guys some time. Yeah. Okay, so I guess if you guys want a quick jump start on how to, I'm just gonna go and create it. You guys can follow, go faster, do whatever you want to do. So when you have it already, everything's gonna exist in your schematic library. Oh, that's almost so for example, I already looked at our AMS 1117. So when I do that, I'm gonna do left click, pull it in, and that's in. So yeah, because I already downloaded it. When you first download something, it'll tell you that the schematic symbol is like on the bottom left. And so how I move around is that you're gonna use your right mouse button. And then left is clicking. Okay, so can't speak today. So is anyone lost on that part?
Yeah, like let's say they don't have that. How do you get that?
How do you get that? So you go to tools, symbols. You're gonna write it in. So AMS 1117.5.0. You search for it, and then unfortunately this software is not great and you cannot expand it. So we're gonna have to go the manual way and use our little slider. So that's interesting. Okay, so we want, it looks like this is only 5.0. So as you can see, like this left part is called your schematic symbol, this right part is your footprint, and this is your 3D model. So that's what you want to look at. And you want to make sure that the symbol and footprint, which is FP, and your 3D model does exist. If it doesn't exist, there's no point. You need all of them.
So which one do you want? The 5.0 or
the 5.0 for 5.0.
Okay.
So I'm going to add it to design. I already have it. If you don't have it, you want to go to your bottom left, and it says like it's placed on your schematic document. Please remember to move it around. Yes. Do you have a question?
I only have one library. Like one in the library.
You only have one.
Yeah. So like, yeah.
Yeah. So that means you have to go.
I don't have a symbol. If that's what you want.
You don't know? That's the installation.
Yeah, I think that is kind of what. Yeah, it is an issue. Referencing is difficult, right? You did point at your phones, the PCB Schematic.
I downloaded the lib and that's in the side. Well, I mean, I was just using Discord and I clicked for the link and it went live.
Yeah, I got the AMS 7 now. How am I supposed to ship that over to like MH?
Really getting set.
Everybody's like really loud.
Learning by doing.
Yeah, sure. Learning by doing. I don't think I'm learning a lot, but yeah, sure.
Like what we just did right now. He does, but I think it's.
To be fair, when I first downloaded the VS Code, this is the kind of growing pain.
Yeah.
I think I spent a week trying to set up like VS Code and GCC.
we need to actually.
So I can run commands like C and
Okay,
Me too.
so you guys have this IC.
that was a pain.
Because I'm just going to speed run now. There ain't no stopping. Okay, cool. We have our first one. You guys have it down. Next one, just keep on going. So you have the 3 point, this is the 3.3. Download next to 5.0. And then you're going to keep grabbing them. So I have the cap. This is my cap I'm going to use.
Let me type AMS. There's a bunch of options. Do we choose the?
Yeah. So the first things you want to make sure are that you have your footprint. So there's a yes and there's a yes, which is your footprint symbol, well, your symbol, your footprint, and then you have your 3D model attached to that design. And then you want to scroll over a little bit and then make sure that, like, for example, the AMS one says AMS blah 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 blah, and that's 5.0. Don't worry about the manufacturer. If you can find it, I think I believe the 5.0. Oh, that's awkward. Sorry guys, it's a dash. I'm so sorry. You'll find the same thing though. Tools. Yeah. Okay. Basically, don't listen to me. Just go on to the presentation. It's still the same thing. You're going to find both. This is just the actual. This is your package.
I mean, the next step was, what was it? What step?
So if you can, find the advanced monolithic systems. If you can't, use the S one.
I saw it, and this thing is
You probably want to choose the 5.0 version. How do you get this? I don't think I do because I'm not having that give me a second. You're gonna go to the next.
Save all, save everything, and then restart. So, random note is Altium is very buggy. So if something doesn't look like it's working, just restart it.
I feel like the hardest job in tech is having
Does anyone have any questions? I'm just gonna leave the bomb up. You guys have the circuit. So ideally, you want to look for advanced monolithic systems. That's your manufacturer. But don't worry about it too much. This is mostly just getting practice. And this is for your ICs.
I'm in the Discord.
Is anyone lost? Confused? No, that's the manufacturer for your ICs.
There it is. Finally.
Yes.
There you go. I did it. Yes, I put it in.
Yeah. So you want to pull up the circuit.
So when you download the library loader, there are these two files right here.
that.
all the work.
So that's the bottom.
Yeah, but yeah. Have you had this yet? Other place yeah, so I just use a tutorial. So when you download that and you download Altium, Altium library loader.
Yeah, it's fine. Okay. Everything's
Generate that button when you download that.
Another thing that might be helpful, you can look on your symbols, but this one I realized does exist in miscellaneous device. But you can still look it up.
Find a directory of that. Go to library preferences, install file, like the file in that directory, and install both the PCB library file.
Guys, I'm just gonna speed run, so unfortunately, Sam is your go-to. Thanks, Sam. Love you. Okay, let's go through. So, we have an IC. How do we flip it? Spacebar, spacebar, spacebar. Have fun with it. C. Yeah, unfortunately, if you don't have a mouse, it's gonna be a little tough. I've never done PCB design without a mouse. I know it's very boomer. Whatever. Okay. So let's create it.
Should be okay.
So your header. 1, 5, 4, 6, 7. Actually, so when you have it, you're gonna hold it, spacebar, spacebar, spacebar. I'm just gonna show you guys mine. So how do you attach a wire? So if you go, so another thing about Altium, which is cool, is that if you go from left, like you're selecting left to right, it's only going to select whatever's inside your selection box. If you go from right to left, it's going to select everything that the box is touching. That makes sense. So like this, if I do the cap, if I do the cap, see it's not inside the box, or it's not fully inside the box, so it's not going to select it. But if I come right to left, it'll select it, and then I'll have to select the entire thing. So a wire, this is a little handy area. Your ground is right there. I don't really use that. What I do is I go to place whatever's on the right of the command is your shortcut. So to put a wire in, I just press Control W, and then my selection tool is ready, and I can start placing a wire. So for example, this guy needs, I'm gonna take it out, but I need a ground there. So right, Control W is my shortcut. I'm gonna left click, press down, left click, press down, right click to deselect. And now it's just like ready for me to go in. But right click, deselect again, ground, add it in, done. Is anyone having any trouble or want like any shortcut tips? It's like coding, but not really.
How do we make the sheet?
The sheet bigger, you go to properties, you go to sheet size, and then Sam says you should use legal.
So if we use legal, should it stay? We have to make our design within that small sheet?
Yes. Nothing can go above the document. Which, yeah.
So we can't just increase it in size just temporarily?
No.
Well,
I don't know how it works.
I mean, you can do it that way, but the way that she talked about before was just that there's a situation where it's not all going to fit in one spot. So you have to break it apart into multiple schematic shapes.
no, not multiple.
Well, that's fine.
Oh.
Yeah, I create links.
Oh yeah, it's like net labels. Yeah. Don't worry about that. Don't worry. That's too much.
Yes, you can just make it.
That's confusing.
Okay.
Yeah.
I made a change to
So just keep creating it. How I did this, if you guys got stuff on your caps or your resistors, usually with the certain footprint creation, there's going to be another area that says value. These ones don't, but don't worry about it because that's only important if you're getting assembled or assembling it. So easier on us. Does that make sense? Because then it's like how a PCB works is you're going to ask to go get it fabricated. That's one manufacturer that's already fabricating it. And then you have to go to another guy and be like, I need it assembled. And then they're going to choose the parts for you. And you have to make sure they have those parts. So that's what the BOM is like when I go to a manufacturer and I ask them to get it assembled, they need a BOM, a bill of materials, so they know what stuff to use.
I keep thinking they meant like a ball.
Yeah, that's what it sounds like.
Yeah, it's kind of fun.
Error there. Another script executing now.
The script is executed.
Yeah, I mean, I didn't know, but yeah.
Wait, what? There's no control Z on this?
Yeah.
Sometimes that happens. And, okay, so also we do have better.
Oh, there it is.
So I started learning Altium design first. KiCad, like I said, is actually not used anywhere. Except for you, like, except to understand PCB design. The only problem is that, so out of the ranking, I was looking at it, so KiCad is free. So everyone that wants to design uses it. The next step is Cadence. So like Cadence Allegro is another PCB design software. It's around $900 per head license. And then Altium is around 3,000 per head, per license. So I think it's interesting because actually, so SpaceX uses Altium, Google uses Base. So I'm like, Google, like, come on, what? Like, I don't know. I mean, it kind of makes sense, it kind of doesn't.
Well, they use
You have all this money.
data analytics.
That's personal preference, but I don't know. Point is, who had good? Who had it almost good? Cool. So like I said, you want to move around with your right. You move around with your right mouse button, select things with your left.
Right now, you're struggling and there's help. Yeah,
Every time I download to documents, somehow it automatically says.
This whole logistics
I mean, I just use the guys that, but like, we're not supposed to go, so, because I'm probably, like, probably. It was the normal legal thing, so, what, hardware, motherboard, stuff.
All the other components.
Okay, for the charger, am I not on the right section?
Yeah, it should be. I think she said the screencast is regular.
Yeah, you can use either the library loader or you can like go into components and go into like go into components and like go to like one of your like simulated generic components and like it's fine with this the default is that one. It's good I get to know that
When I look for it, and then it tells me that I cannot ignore it.
Oh wait, no, they don't. They teach like they should go one for them.
I think my major. Wait, what? Oh, I just went to the drop down menu.
Oh. So.
Yeah, so
Okay, it's me. I'm glad you figured that. That's
So it's like this. Yeah, the looking like this. So it's like you're putting like AND gates or zero.
Oh, wait, we have to.
and then apply. And then your wire.
Oh, manufacturing.
You guys want to zoom in and out, obviously control zoom in is normal. Or you can also like hold the little wheel and zoom in. And that works too. Anybody else have questions? Yeah, so, yeah, so what I was saying is that like these plans that have values. Also, don't worry about the, wait, just so that everybody knows, don't worry about those little question marks. You can worry about them if you want to. Feel free to, take care of that. But I want to show you guys a neat trick so that you can just annotate everything. That's called annotation. So that's why I put the cheat sheet, which is highly annotate.
Oh,
So,
thank you very much.
any more questions? Any questions at all?
How do you find it?
No, it's okay.
Oh, yeah, just go.
Yeah.
But like,
Okay, I'm going to show the bill of materials. So you guys can have that. So, we have not touched PCB design yet. Okay. Okay, so we have not touched PCB design. Just so you guys know. Yeah. So this is usually the electrical engineers part. I'm gonna leave it up to the room. So right now it is 7:33, and we do finish at 8. So we can go over PCB design now, so you guys are ready, or we can finish up schematic for 5 more minutes and then go to PCB design. But the big hoorah is that if you guys do submit your projects by Sunday at today's Friday, by Sunday 11:59, we will manufacture your guys' PCBs. So that's super fun, and I have to take care of all that. So that's even more fun.
Where do we submit?
Just on the big Hyperloop program.
Yeah, or I'm gonna send out my email, and you guys can send it to me, and then I'm gonna create your Gerber files because we didn't have time to shut. By Sunday 11:59, if you guys have everything done, I'm gonna edit it and then send it. It's either that, or we're gonna send you the ones that were created, and you guys still just think about it.
The hardest part is
That's literally every single like software tech thing.
Yeah.
See, when I've done all the installation, yeah.
drag and drop.
Wait.
Well, what is the virtual,
Okay. The circuit.
yeah.
That's what I do. I totally use net tools.
Thank you for your sacrifice. Okay. So we just hit another issue. Remember Control S. I redid this board 3 times so that not Control S. Any questions?
So what we're gonna submit is like we're gonna create
It is very, very important.
No, so that's just schematic. So we have to do the PCB design as well. Yeah. You guys are the electrical engineers right now.
I really new.
Yeah.
This is my first semester.
I know it's very confusing. I didn't really know.
Yeah, so yeah, but I don't really have a clue what
Yeah, so we're gonna get that in 3 minutes. So you guys have kind of
So
3
you guys have
minutes.
like 20 minutes.
Yeah, there's a lot of things to learn. That's what I was like, yeah.
Oh, so 1 and 4.
Yes.
Resistors, can we find 10K? Can we change the value of the resistor?
You get like a generic.
Yeah, so don't worry about the values because we're gonna be the manufacturers. We're not gonna assemble on-house. Yeah, just put a resistor with that package size, and then you can label it. The point is, I'm gonna hit the very edges of the design now. Okay. Okay. So, who has it more than 50% done?
I'm getting the left side done right now.
Okay. It does take a while. It's kind of nice when you just like zone in and like have headphones on and just like ignore everybody around you.
Muscle memory on this.
Yeah.
It's fun.
Yeah.
You gotta go in.
Yeah. I mean, electrical engineers, like, usually what we would do is like you have to choose every single part, which is tough. I like playing with puzzles. Huh? Yeah, so usually like how this works is like what I was telling Sam, is like your customer comes in with a certain like set of requirements. This is how like PCB is formed. Your customer comes in with a certain requirement being like, I want to ship a phone. I don't know. Fine. Okay. We want to create a phone. A phone has to have what? It has to have RF in it so that you can talk to people. It has to have some kind of computer sets that it can actually work, so there's different PCB requirements or different electronic requirements that you have to do. And then the electrical engineer is like, okay, well, in order to create something that has RF and that it won't shock somebody, for example, as also, we have to create the circuit. And then the electrical engineer comes in and is like, oh, well, in order to create something with RF, we need a voltage regulator in there. And then what they do is they choose every single chip. So this is what Chris did. Chris created the circuit. I guess this is also very generic, but he still created it. Point is that he created the circuit. He's like, well, I want to choose this capacitor. It needs to be 10 microfarads because of my calculations ABC. I want to use a green LED because green means go. I don't know. And then he creates the circuit. These get very complicated. And so the electrical engineer has to do a lot of math. Yeah, that's how it happens. And then the mechanical guy comes in, creates the chassis. And then PCB designers come in and create PCB. Huh? I'm computer. I'm more like electrical, but I am realizing I am not. Circuits are rough. There's a lot. Because like I think like now you're talking about like power design versus digital design. Now you're talking about RF. He does RF, which is like insane. Like RF is basically just like black magic. You're like working with freaking, like that's literally what we call it. It's just black magic. Like you aren't really working with anything. It's crazy. It's so crazy. So there's like emphases too. Yeah.
I cannot see it anymore. I don't remember. I added this AMS one thing.
Okay, in 1 minute we're gonna get to the PCB.
This is not like, is there a stack overflow or like lots of?
Yeah, this one, I feel like they're like like creating like the VS, like Visual Studio Code.
Library loader, man.
It's like the same situation like when you're trying to download Visual Studio Code and like everything's everywhere.
It takes like 2 hours for the setup in Visual Studio Code.
I know. It takes me like 5 hours. Thanks for helping. I know.
Now I know how to install Altium like 5 times over.
That's good. Okay, guys, it's 7:40. We are going into PCB design. Okay, so let's pretend, even if you don't have it finished, still walk through it with me because it's the same situation. Because during an electrical, during a project, you're gonna have a bunch of revisions. Like for example, like 2 weeks into a project, electrical engineering. Don't be this person. I'm saying this now because I despise these electrical engineers, but it's okay if you do it because it's normal. Point is that when you have a circuit in, sometimes electrical engineering, you're like 2 weeks into the project, you're like, wait, I want to change like 50 components. And obviously this is terrible for us because it's like you're basically redoing the entire project. But it's only understandable because they learn new things. But so when you have everything done or whatever you do have done, I assume that a bunch of your components are like J question mark, D question mark, C question mark. So this is called annotating. How you can kind of speed run through it really quick is you go to Tools, Annotation, Annotate Schematics quietly. I already did it, so I can't change it. But usually when you do that, it'll automatically just populate like R1, 2, 3, 4, 5, 6, 7, 8. Yeah. Which is really nice. Saves you a lot of hassle having to figure out if you have 2 S1s or 2 R1s. So that's nice. So once that's all done, usually the electrical engineer will come in and they'll validate everything. We don't have to worry about that because I'm trusting you guys as electrical engineers to make sure your things are validated right anyways. But usually they'll come in, press validate, and then make sure that like there's no wire hanging, everything works right with the software and that the software can cooperate correctly. But despite that, don't worry about it. You're gonna go to your PCB doc. So I already made mine. So this doesn't really work. I'm gonna do this. Copy this page. Yeah.
So okay, once you have the schematic, so automatically, like, it can be translated to the PCB, or you have to design it as well.
Yeah, so I'm going to show you that. So right now it doesn't exist in your PCB, right? So this is, I'm using my little middle thing. I'm just going to keep telling you guys so you guys eventually understand the shortcuts. You can delete it. You can just select left to right. I'm going to paste it in. Oh, that's this way. Oh no, it's not fitted. Oh, that's what. Sorry, Stan. I'm just being a little bit too. Oh no, my thing's lagged up. Shut up. Okay. So what just happened was I copied from my outline that I already did. I'm gonna annotation, annotate schematics quietly. Yes, it's all done. Very good. So remember Control S, save all the fun stuff. Then when I go to my schematic document, you'll like see black. This essentially is your PCB. So if we go to our panels page, properties. This is your holy grail. Like you guys definitely need this open because it's going to give you all the access to everything you need to look at. This properties panel is very important. View configuration is very important. I know it's going to get a little confusing. Just bear with me and we'll go jump into everything. So this is your board outline. This is your board background. Everything that exists on the actual PCB, when you fabricate it, assemble it, everything that you work on it has to exist within this black square. All the colors are fake, so you can also choose what colors you want to do. If you want to do the same black background, feel free to. But the problem is that Altium notices All right, now we're gonna create a board outline so that it actually recognizes this black area as the board outline. Informally, it sees that this black area is the board outline, but when you actually have manufacturing, you can do that. So because I'm understanding this is like very new to everybody, so I'm gonna run through it for like 2 minutes and then jump into it. So these are your layers. So you have signal and plane layers, component layers, mechanical layers, and other layers. So your signal and plane layers are where the electrical outlets are, essentially, or platforms are. So all boards come in an even number, 2, 4, 6, 8, 12, 10, whatever. This is because of how a PCB is formed. Usually you have your plating, you have your core, your copper core, a dielectric, and then a copper core, and none can exist without the other. They all come in even pairs. So we're only doing a 2-layer board. Well, I was saying earlier that it's a 2-layer, one-sided board means that the components can only exist 3D modeled like this, like upwards towards one side. You can't add components onto the bottom layer. You can change the colors, all that fun stuff. So that's your signal and plane layers. Plane layers essentially are the negative version of your signal layers. I'm not going to get into that, it's just confusing, especially if we're not going to do it. But yeah, so that's that. Component layer pairs. So you have your overlay, your paste, and your solder. Your overlay essentially is your designator, so it's the annotations that we saw. This is my PCB that I made for this project. So if we look at the 3D model of it, these are your overlays, your designators, they call it. So you have the top one, you have the bottom one. We're not doing any on the bottom, so nothing needs to exist on the bottom. Just taking the overlook of everything. This is the header. These have 3D models. As you can see, the diodes don't have 3D models. If I want to move it around, depending on how nice your computer is to you, it'll actually move around. Yeah, so that's that. Your paste, don't worry about the paste, that has to do with manufacturing. This is just so that your manufacturer knows how to assemble your PCB. Your solder is your solder, as you know. And then board outline, I just made a new thing, but don't worry about it. So this is like, notice the Altium notices that this is the board. Mechanical one, there's whatever mechanical parts are part of your footprint. So this is how they know like how to manufacture it, where the dimensions for what are where. So like if I click on here, so this is, I believe, the 3D body. So this is a 3D body outline. This is like the 3D body interior. Oh, I'm not a mechanical engineer, so. The point is that yeah, every single layer is very important. It's nice when you can kind of like show what's on every layer. That's why it designated this board outline. But don't really worry about these 3. Don't delete them. Very important for your footprint. But that is that. This is just some other fun stuff. Don't worry about that. And then your view options. So this can kind of go into the definitions of everything. So, okay. This is just kind of how your computer configuration is in the present moment. So right now, I don't have any of my 3D models on. I'm in single layer mode. So it's on mono because I'm only seeing one layer. How I changed to a different layer was Control or Shift S. Shift S. This is all of the other presentation ones, so here's my shortcuts to that. That'll be there. You have your paths, so you can change the transparency of all of it. I'm gonna take this out really quick. So that's a polygon. So you have your paths, which are these little, like that's actually where the component is. That's making an electrical connection. You have your vias. There's no vias in here. These are called through holes though. Vias are like separate holes that are a part of the component, which there's different kind of vias, one that drill all the way through. Then there's one that's are like lined, which they are inside of the board. There's that's buried. Buried are like buried vias are inside of the board. Blind is like halfway through the board. We don't work with those unless they're very sensitive situations, and they're also very hard to manufacture. That's just like knowledge. But that's that. Arcs, tracks are your routing, so these are like little tracks here. Polygons is that big red piece that I just took out. Polygons essentially are copper pores. So, does anyone know the purpose of a copper pore? Okay, that's okay. So a copper pore essentially is copper the entire pore. Otherwise, it's just gonna be like black, or this would just be like green. But the point of the copper pore is that, like for example, when you have ground signals, you want ground relative to all signals, right? So that there's not that much disruption in the noise. That's very important. If you have high voltage, high current signals, having more copper there so that there's better heat distribution, that's very important. So like if I show you guys here, just some background on design. Okay, so the copper pore is entering into this capacitor, these capacitors, because these are ground pores. My copper pore is designated to ground pore. And it's also very important, like the pore can just spill all over into the pad, which is bad for manufacturing situations, but also just like thermal situations. So this is called a thermal relief connect. So that's a polygon. A region is exactly the same thing, but you can kind of be more flexible with the region. There's more things you can do with it. And don't really worry about that. So for you guys to get into your project, to even start.
Is it upper core in between the two PCBs? Like how big is it?
It's just like a flat plane of copper. Because otherwise it's just blank area. Does that make sense?
When you're making a PCB, if I understand your question, essentially what the deal is that you basically have layers of fiberglass and copper built up, right? And when we have a core, it literally means like they actually place a flat sheet, like a core of copper on that area. Cores can thermal releases can be good. They can be used for rounds. They can be used for a bunch of different things. But for the most part, they're mostly used to like what you said. Yeah, it's just they do core it though. I think it is like voltage. So I think they do.
Yeah, so you basically have a flat signal or multiple signals. You do multiple copper cores on one layer, so it doesn't even have to be on the top or bottom. It can be internally, but it's just to have a relative like signal throughout the entire board or pieces of it. Sorry. No, they should be on all layers. Yeah. I think like fair. No, it's okay. Fair like point is that if you have the money, actually it shouldn't even cost that much if you do that. But
it's like I've seen it. The way that they do it sometimes is they do like a textured thermal release as well. They do kind of a pad, but it's like not quite either. Like they're still fiberglass.
right.
I've seen it to make it look pretty, like on some stuff too.
I don't know. Well, like standard rule is that you want a copper core on everything, and if at the very minimum have just ground when you can.
Yeah, that's what I do. I do use ground, and I don't really make two-layer stuff.
The only thing is like the second layer on that is that if you have copper cores on every single layer, to disconnect them from your connectors, not on all. Yeah. Okay. Sorry, we need to run through. Okay, so now that you have your schematic document, whatever you do have, how are we going to place into the PCB, right? So you want to go to design. This is in your cheat sheet too. It's in both of the workshop files. Import changes. And in this segment, you're going to see like a bunch of different changes. So it's going to say, I want to add all these components. You can select, deselect. Usually if your schematic's correct, it'll add everything in. It's going to add nets to every single net. So the net is a wire or the pad or whatever signal connection there is. And then yeah, your room is essentially your schematic document because all that circuit, all those components exist in that room, in that schematic document. But those are annoying, so don't worry about them. So once you have them, you press execute changes. And as you can see, everything is good to go. I have green check marks. If there's X's, game over, buddy. There's no if you have X's, that means that there's something wrong there. It already exists. That probably might mean you have double net label. Yeah, you're right. So just here, the message will tell you what's wrong. So that might be you have two of the same components under different, or two of the same designators under different components. If the footprint doesn't exist, blah, blah, blah. Point is, now you press close. So now that we have everything imported in to the schematic document, now you want to start placement. So this is what I was talking about, is that this is the room. It gets kind of annoying. So like if you move it, it moves everything. And that's even if it's not inside of that red box, which is quite annoying, especially if you don't realize it. So if you don't want to touch it at all, you can go to View, Rooms, and then you don't see it anymore. Ignorance is bliss. So now you can't even touch her. Sorry, DI, that's not nice. Point is, we're gonna go to IC, like we can start with the IC, or you can start with whatever way. So the interesting thing is that your schematic will not exactly look like your PCB. Your schematic is just an informal way of connecting all the signals together. So how do you create a good PCB design? I'm gonna go off of this. When you guys create yours, try your best not to look at minor curses, just because it's more interesting, like, but you know, whatever to you. So I'm just gonna kind of show how my thing worked on this PCB. So what I started with, I did this 10 times. So it's gonna take some time. It's kind of nice, class and music on, everything's fine. Your most important components on the schematic are kind of the baseline of how you start. So the most important components here are your voltage regulators, right? So I'm like, okay, I want to work with those two the most. And then what comes after that? Well, in order to filter out the signals that come in and the ones to filter outside, they have to hit those capacitors first before they enter into the IC. Because if I were to connect from here to here, just get the capacitor, there's no point. It's going to have really noisy signal and your PCBs not going to work. So that's not nice. So I added these two capacitors, or 4 capacitors here. That's how it worked. And I was like, okay, well, we do need some switches around them. And I need the switches to hit before or after the capacitors. So that's why this one comes here. This one, there's kind of a little bit of a leniency, especially on how complicated your board is. Well, the reason why I'm saying that is because in the schematic, so like the node exists in this net, these 4 nets, right, to connect over the switch. Essentially what I wanted was that I wanted more of a clean output to recognize when I can go like use the header and see what my signal looks like. So it would be best practice to go from here to there, but this kind of does the same thing. Like they're all still connected to V out, which is the signal, this is ground. Like, you know what, still works, it's still good. There's not that much current, not that much voltage, we'll be fine. So that's one thing I did, and then how I went backward was like, okay, well, these diodes need to work, so the resistor has to come first, right, before the diode, but opposite electricity doesn't make sense. So you go from capacitor, well, this net, capacitor to resistor. The diode enters first before any of the entire circuit. So I was like, okay, this has to be here. Well, the header goes to switch, that's very obvious, then diode. And big aha moment is your electrical setup on your PCB will be pretty directly correlated to the aesthetic of the PCB. If that kind of makes sense. This isn't like that nice. Like I prefer it was like, I don't know, I should have figured out a better way. But you know how like the symmetry kind of like works? So electrically, not saying it will work, but kind of the idea of how electric forms is it wants to go in a circle. So it like, or it wants to go straight. So the shortest path of resistance is like the big big idea. So kind of, if you can see the electric flowing, it's going from over here. So if you look at every single area, right? So the resistors and diodes are its own area. That's its own signal circuit. The ICs are its own signal circuit. There's other diodes that have their own signal circuit. So if you look here, there's one little circle here. If you look at this area, there's one little circle over here. If you want to go up there, it kind of goes this way. Oh, sorry. If you want to look this way, it's going to go up here, then go that way. That's another circle. Over here, there's another little circle. Oh, here, there's like a huge circle because there's ground on the entire thing. So everything's consistently flowing. That makes sense. That makes sense. So that's a good idea to follow because then, like, it's very, up to your take of like you just have all these components posted onto the PCB dock, so you can place it anywhere, right? Which means there is no really correct answer until there is. Like when you do RF, there's a correct answer to that one. Everything else is no correct answer. So that's good to keep in mind. Like you don't want to go backwards. Like I don't want to put this over here. It doesn't make any sense because it has to go here. Because otherwise it'll go this way, back and forth. That's the opposite. That's not good. So you have this little circle, circles. And like this obviously can't be over here. It wouldn't make any sense. It needs actually, it's going to create this entire large circle. So the smaller you can make the circle, the better. Which is just electric flow. It's faster, which means it has better signals coming out and in. So that's do you have a question?
What resource can you recommend to is YouTube a good enough resource to learn some of this? Or do you have something else that you want us to look at?
PCB design? You're saying PCB design in general?
Yeah.
So that's the funny thing about why I think like these workshops are kind of important because I fortunately got to learn PCB design on the side because my dad learned it first. So I started as a librarian. And then that's when I started taking on like more designs and do my own contracting work. Then otherwise, PCB designers aren't actually like, you don't really learn it until you actually have some experience in the field. So that's why like, as right now, you guys don't see any classes on it. It wasn't until like my manager and I talked and I was like, this exists, like how are you going to learn about it? And he's just saying like, well, you gotta take like 5 years and work till you learn it. Cause like, like startups, obviously you have to do a circuit and then you have to be the PCB designer as well. But it's like, okay, they'll just like teach you or they'll make you figure it out otherwise. Or there's like great clubs that do it. But I also, there's a few YouTubers, but it is very hard to get in the space because also like there's no entry level PCB designer. That makes sense.
That's kind of true. Like you can't just like kind of just walk in.
Yeah, you can't just walk in and do it. Like usually a PC designer, a good PC designer has to have at least 5+ years if they want to hire you.
Yeah.
And you also have to have experience in like high stuff. So like high power, high current. RF is a little bit like more senior stuff, but like analog.
I deal with RF because that's like the research. The thing is that like, like for me, whenever I kind of see like a certain trace or certain ground cores or whatever the case may be, I always tend to think about how things are set up magnetically, right? Because it's like, whatever the case may be. And I think the earliest example I was ever introduced to something like that was honest to God Cat5 wiring, the way in which they basically twist their individual pairs together to magnetically cancel out how that worked. And then that sort of like ensued my interest in this. But I am like nowhere near as good as like some of the folks who work at like Keysight or like any of these companies that actually make like, laboratory grade equipment, radio stuff, because those guys are like, I mean, like they understand how magnetic interference actually does work. They have tools, they have money to actually like determine, test in this dumb little MATLAB simulator how pretty much everything interacts, right? Because as like big small brain as you are, it's really difficult to imagine more than like 3 points of interest in RF wise. So that's like kind of the same thing as that. It's not like Photoshop or any of that other junk either, where it's like you can kind of just go online and then start going at tutorials and finally, like sooner or later, remembering stuff that you learned about different processes for tutorials and just kind of forming your own. This kind of thing, I don't know, it's, it's kind of like that. I think, actually, now that I'm thinking about it more, so like if I were to look back and get a headway into it, I learned it because some person told me that I learned PCB design just in like it was like legitimate, like, and I wish I was lying, seriously. It was like, me and this person was not getting along, and this person was like, yeah, well, you're just stupid, you can't even like grade like something. So I'm like,
to be fair, I start coding out of spite as well.
yeah, exactly.
And now I'm just doing it for fun.
It's just, no. But then I met Vic at the same time. She kind of taught me the same things.
I started coding out because it's fun.
Yeah.
I actually
I
started
think-
doing music because it's fun. I start a lot of skills because no, it's just like because of my friends. They always shit on me because like they think
Those
they
are
think I'm
not
shit.
friends, I guess.
I think,
Well, they're high school friends. They're not friends now anymore because I'm in contact with them.
okay.
So,
All right, let's hear it.
Okay, let's wrap it up really quick, and then you guys can hang out. Wait, let me answer this question. Okay, Chris, your question. If you want to get like a head into PCB design, or even just like to be a better electrical engineer, things I would know is to look at DFM, which is Design for Manufacturing. So this is actually telling you standards of like DFM. It's called DFM.
Oh, yeah.
DFM, Design for Manufacturing. This is very important on how you standardize like your guidelines on manufacturing PCBs, for example. Like with this certain current, I actually just realized this is free too, so wait. Oh man, I already shared it, whatever. Okay. I want to just this for the room, but this is a really good toolkit. It kind of goes along DFM. It's like DFM into a software. It's very handy, Sam. You should use this. Like I use it all the time. Oh. Okay. Don't give me that face. No, it's like.
No, it's funny because the engineer that I'm working with showed me this like last week, and he said you should start using this. Just gotta.
No, you like need it.
Yeah, I know you do.
Yeah.
Yeah, I know.
It's okay. But yeah, so this is like very helpful if you just kind of want like a little calculator to play with, because it'll like show you like conductor properties, which is like for certain copper and this much copper weight, like how many amps can it suffice, which is like 1.5 for a 15 mil PCB or 15 mil conductor. This is really helpful. So DFM, I would say, and then also Altium, like the actual website, has a few like it's like an information overload to take it easy. But there's like a project tutorial, so it'll give you like a circuit, and you can rebuild it and then just like rebuild stuff. And then like it should show you the final outline that they did, and you can kind of compare it to yours and see like what designs you can do better, because that's how you become a better PCB designer. And that's why they say 5 years is good, because otherwise you would just kind of be playing with puzzles. Yes.
So when you get to the PCB point, just the one there, the next step in there is just the electrical engineer comes and verifies it, or not even, or how, from there, how do we get our action?
Oh, you're saying you, or you're saying in general?
Well, in general, like this is the final step of the design.
Yeah, so the steps.
The way you want it.
Yeah, so like let's say I was like, okay, this is good, right? Is that what you're saying? And then what goes on after that?
This is good, I like this.
Yeah, okay, so I say this is good, and everyone's like, I don't know. So usually like how it happens is another PCB designer comes in, they do it, they call it an internal review, and then they kind of check mark everything, because it's not just like, we kind of went over the simple stuff, but there's a lot more in, and that's why Saturn is useful, because there's certain rules that you have to follow. So when you load an Altium as a software unit, it comes with the rules already, but very, very vague rules. Like this is like for our design, like very simple, that never exists. And usually I'll have it already put in, but the internal reviewer will look over that. I'll make sure like the placement's good. Like if I didn't check for things I didn't know. On top of that, they'll take a look at my documentation files that I'll send over to the manufacturer. So usually there's like Gerber files, Draftsman is another software they use, or like drill drawings. which is like where is the dimensions for the drill? Is it exact? How can we change it? And then usually after that, then it's good. So usually the internal reviewer, which is another PCB designer, checks it. The mechanical engineer checks it also. The manufacturing engineer checks it also. So you have a bunch of checks. And then once you're done with those checks, the RE, which is the responsible engineer, or your electrical engineer who takes care of the entire project, will come in and check it as well. Once they give it a go, then your project is ready for release. Usually the electrical engineer will go and like purchase it. And then it takes like however long to come back. And when it comes back, good, if you're a good RE, you'll show everybody that worked on it with PCB, but usually they do. And then otherwise they'll like show you it, and then they're gonna go run for testing. So they go into the test lab and use their little probes and test everything.
How do you get the sides to be?
Oh, like that? Yeah, corners. So kind of drag them. So when I like touch the corner, it's gonna drag into a 45-degree angle. If I use oh, it's not working, this is the line. Sorry. Hi, thanks for coming. Let's do something. So if I, like, let's say there's a 45-degree angle. I set this in my thing, but if I want to create it into like a different, like this is like round, you do a Control C, I believe. Oh wait, no, it's a shift space bar. So that's like round, that's 45-degree angle. Yeah, I learned it all by myself. Yeah. Okay, I don't want to keep you guys, so you guys need to go. Thank you for coming. Appreciate it. If you guys have questions, feel free to message anybody on the board. I realize not everybody. Thanks for coming. You can submit it to my email. I'll post it. Yeah, my email address is. I think the situation is that either we're going to get your board fabricated or we're going to get our, like the boards that we created fabricated. But this board will come out to you if you attended today specifically. If you didn't attend it. Yeah. Like, yeah. I know, but you don't really know it until you know it, you know?
Yeah, I do. I know it. Did I just think about it, and then I'm like, okay, it's good. I don't even know what tool to
It just kind of helps with the, you know, like when it's like you actually put on PCB and actually.
I haven't ran into that.
From here, this is after the import, so there was an error. One of my resistors is connected. I think that's the problem. But from here, how do you get it from like nice
Route.
Huh?
Route. You got a route?
Well, you have to place everything first.
Yeah.
Yeah.
So you have to place everything.
Place everything. And how do you do route? Track. Oh, and then it'll make it nicer and stuff, and then I can adjust the corners and everything. Okay.
And also, go to your turn off. I just want to keep like bugging you and fidgeting and stuff. It's like your rules, but you don't have to worry about it. It's good seeing you.
Good seeing you too, yeah.
Oh my God.
Thanks for I was at your PCB workshop last semester.
Yeah.
But it was online, so it was a little hard to understand, so I wanted to come here and clarify some stuff. Yeah, yeah, no problem.
So I had a question about like when you're designing it. So when you make the schematic, then you kind of import it into the PCB. So everything is always like it's already connected. So you just kind of like drag it around so that it's like properly laid out. And then all the like copper core stuff, is that all just like done by the software?
You have to create one. It's in the other workshop.
Oh.
Yeah.
So is that gonna happen later?
Well, like in the other workshop presentations I created. But either way, like it's also just for your practice. So if you have any questions, like feel free to let me know. because the situation I think is that we're gonna, whoever can today will get their own PCB for the regulator. I don't necessarily know if it's someone that you create or if it's someone with.
Oh, so do I submit that myself?
Yeah, feel free to, yeah. I think so.
Thank you.
Yeah, thanks for coming.
And I couldn't recover my data, but
Bye! Bye!